today we're going to do 9D. I've heard lots of people pronounce it lots of different ways. I've heard Bezier, I've heard Bezier Curves. So it's named after a French guy who developed the technique, and I've got a list of where it's been sort of used before, but they've used it in like designing cars, okay, in the framework of cars. But it's a way for us to develop a parametric curve that goes through a number of points. Now for our purposes, the most amount of points we will go through is 4, which means the highest degree of a polynomial will be x to the power of 3. Alright, so that's what it says very clearly in the subject outline. So this skill is not particularly hard, it's just like you're just very methodical. We're just going to make sure we're putting it in the formula correctly, so there's just a little bit involved. It's a bit of a tedious process really. Okay, so we've got the Bezier curve that, I'm going to say Bezier. Alright, we've got the Bezier curve that makes up these points, and composed of those points, and the equation of the curve is going to be x of t being equal to something, and y of t being equal to something. Alright, and so we need to first find these coefficients a, b, c, and d, and the coefficient a is going to equal the x coordinate of the third point. Alright, the third point over there, sorry. Take away 3 times the x coordinate of the second point, plus 3 times the x coordinate of the first point, and then take away the x coordinate of the last point. Alright, so what we're going to do is we're going to go through, find all these values for x and all these values for y. So it's going to take a little bit. So let's get straight into it. So here's ax, okay, we do with this one here. We're going to have x3, which is this one, minus 4, and then we have take away 3 times x2, which is positive 4, and then we have plus 3 times x1, which is 14, and then we have take away x0, which is 0. And so we've got minus 16 plus 42, what's that, 26. Alright, and that's all we're doing, so we're just going to rinse and repeat that. Follow the instructions for bx. We have 3 times x2, so that's going to be 3 times 12, take away 6 times 14, plus 3 times 0. So minus 82.
Where 12 from?
3 times 4 is 12. I'm jumping again. 3 times 4 is 12, and that's minus 84, so minus 72. Cx. 3 times x1, so 3 times 14, take away 3 times 0, 2, and then dx will be 0. Any issues? Okay, so this means the x equation, right, it has this form. It's a t to the 3 plus b t squared plus c t plus t. Alright, that's going to be the parametric equation of it, and over here we've found the values of a, b, c, and d, so we're just going to shove them in. So we've got 26, take away 72, plus 42, and then we've got 0, so we don't put them here, that's 26. Okay, so now we're going to repeat that for y. And it's the exact same for y, except we're using the y coordinates instead of the x coordinates. So I might go through, I might just rub it out if that's okay. Any issues? So we'll do it for y. Alright, so we have y3, which is positive 2. Take away 3 times y2, which is 0, plus 3 times y1, which is 10, and then take away y0, which is, I've rubbed that out, is that a 0?
Yeah, it's 0.
0, 0, yeah. 0, so what's that? 2 plus 30, 32. For by, 3 lots of x2, y2, 3 times 0. Take 6 times 10, plus 3 times 0, that's minus 60. cy, 3 lots of y1, So there we've got the parametric equation that describes the Bezier curves between these points. And the way we can draw it on the Cartesian plane is we can plot these points, all right? And then we can use technology to help us discover the curve that passes through all four of them. Okay, so not particularly hard, right? It's just follow the instructions, but easy to make a mistake when there's a lot involved. Okay, so that's the first part, just finding the equation of it. Next, let's move on to question 2. And we've said we've got here a Bezier curve composed of these functions. So we're given the x and we're given the y. So we're not given the points for which it's valid. So we've got minus t squared, take 10t plus 2. And we've got 2t to the 3 plus 3t, take 5. Or we're restricting the parameter t between 0 and 1. And that is always the case for a Bezier curve. Okay, so if you have a look, for a Bezier curve, we always go between 0 and 1. All right, so if we've graphed that, I did it a bit earlier, so I'm just going to provide a rough sketch of what it looks like, because that's what they're asking us to do. So I've got when t is 0, right, and you can get this point straight away, you've got x is 2, y is minus 5. So 2 minus 5, that's going to be the first coordinate, P1. P0, I should say, the point when value of t is 0. And then the last coordinate when t is 1. Alright, when t is 1, if you put that in, I got x is minus 9, y is 0. So that here, I might write the coordinates actually, so we've got 2 minus 5, and 9 and 0. And if you graph it, it follows a curve in between, basically like that. And remember the pitch, okay? The pitch is going to say how many iterations am I performing over this, like what's the distance of an iteration I should perform, and so we should set that to a low value such as 0.1 in our V window. So we've got P0, and then this is the final point, this is P4. Okay, part B. Determine the domain and range of the Bezier curve. So when we think about the domain, all right, we're talking about possible x values. So we go, what's the point furthest to the left? What's the point furthest to the right? So it exists between 9 and minus 9 and positive 2. That's the domain. And then the range is going to be the y values. So we're going from the bottom to the top. The lowest y value minus 5. The highest y value is 0. And then part C. Hence, what's the leftmost, the rightmost, the topmost, and the bottommost points. Okay, so the coordinate that's furthest to the left is minus 9, 0. The coordinate that's furthest to the right is 2 minus 5. The most bottom point is 2 minus 5. And the topmost point along the curve is minus 9, 0. Alright, now that won't always be the case, it's just so happened that it is for us. So a simple circumstance where it wouldn't be the case is if it went down like this, okay? In that circumstance, right, your bottommost point is going to be down here, alright? And that's going to be the lower value of your range, isn't it? That's going to correspond with the lower value of your range. Alright, so just be aware of that when you're encountering them. Cool, so let's have a go at this exercise.